Hello everyone, and welcome to a video with, well, a bit of a different format. I've dabbled in the area of 3D modeling for some time now, and decided to combine both of my skills to create this informational video on how a clock works, specifically an American-style 8-day clock movement. I based the model off a Sessions mantle clock movement, and is quite accurately represented here if I do say so myself, despite missing a few parts that I didn't bother modeling for the purposes of this video. With the time train isolated here, we can begin to take a closer look to see how everything interacts. We will go step by step and wheel by wheel all the way up to the escapement wheel. To make things easier to understand, I'm going to break things up by removing part of the train from this view, as we will be going over that area a little later on. And with that removed, we are now ready to get started. The first wheel in the train is called, well, the first wheel. However, it is most commonly referred to as the main wheel. And one of the reasons that it's also known as the main wheel is because, well, it's the main wheel of the strike train. Behind it sits the mainspring, which is the powerhouse of the entire train. Both trains contain a mainspring. At least that is with these particular style of movements. The reason this wheel is so massive is because it needs enough strength to be able to handle the force of the mainspring behind it, as well as allowing the correct number of rotations within a certain amount of time, so that way the clock can run for its designed runtime. This one is designed to run for 8 days, which equates to approximately 9 revolutions of the wheel. The next wheel in the train is called the second wheel, which is connected to the main wheel via a pinion gear, which is basically a smaller wheel that helps to change the ratio of rotation between the main wheel and the second wheel, as well as all other wheels in the train. A quick side note about pinion gears. This particular style is called a lantern pinion due to the fact that it, well, resembles a lantern. Also, the second wheel serves a dual purpose, which I will explain later on in the video. The next set of wheels in the train are called the third wheel and, as you may have guessed, the fourth wheel. The main function of these two wheels is to continue to change the ratio of rotation until you get to the escapement wheel, which is the last wheel of the train. The escapement wheel is quite different than the rest of the wheels in the train in that it has angled teeth. In this instance, the angled teeth serves two purposes. One is to allow sliding motion against the pallet so it can power the pendulum swing more efficiently. The second reason is to allow room for the pallet to fall in between the teeth without binding. Also, a common misconception is that the pendulum drives the clock. In this particular instance, the spring is what actually powers or drives the clock. The pendulum's purpose is actually to regulate the accuracy of a clock's timekeeping ability. And this is done using the rating nut, which is usually found below the pendulum bob itself. Turning the nut to the right raises the pendulum, which slightly shortens the length and makes the pendulum swing a bit faster. The faster the pendulum swings, the more times the pallet ticks with the escapement wheel in a given time period, therefore making the clock run faster. In contrast, turning the nut to the left lengthens the pendulum, which makes it run a bit slower. Using these principles can help make your clock run more accurately. Okay, so now we've gone through the first part of the time train, which leads up to the regulating assembly that I've just described. The second part of the time train actually isn't considered to be part of the time train, since it branches off from the second wheel and forms yet another train known as the motion work assembly. Let's take a closer look at the motion work assembly or train, as it can be a bit confusing to see using the viewpoint we've been using thus far. As we've already covered, we have the main wheel and the second wheel from the time train. Branching off from the second wheel, we have the minute arbor with a transfer wheel and pinion, where the minute hand attaches. Then we have the transfer arbor with another wheel and pinion. And the last is known as the cannon wheel, or what I like to call the hour barrel, as this is where the hour hand attaches. To best show the actual timekeeping portion of this style of clock movement, we can actually remove the main wheel from view because its main function is to supply power to the train, as well as regulate how long the clock runs for, which we covered earlier on. So basically, the regulation flows from the escapement wheel to the fourth wheel, to the third wheel, to the second wheel, and finally into the motion work, which is where the hands attach to show you the time of day. And there you have it, the complete time train along with the motion work train of an 8-day American-style clock movement. The strike train will be covered in a separate video at some point in the near future, so if you're interested, please be sure to hit that subscribe button to view it as soon as it's uploaded. I hope this video has been informative and helps to relieve any anxiety you may have if you're interested in attempting clock repair. If you're seriously looking to enter the world of clock repair as a hobby or even as a possible profession, I highly recommend getting some literature on the subject, such as the series written by Philip E. Balcom. Also be sure to like this video if it's been helpful, and as always, feel free to comment below with any questions or feedback. Until next time, thanks for watching and have a great day.